Hi, everyone. This is Mr. Wilkie here, and this is a recording on some algebra skills that might come in handy for you as you transition into one of the grade 11 physical sciences, so either chemistry or physics. First off, um, I want to make sure that you understand that this is really a way for you to get a leg up or some basic skills that are going to make you more successful. If you struggle with what I do today, then you need to reach out and you need to say to your teacher next year, I've got some deficiencies in the algebra and solving for a variable. So there's no judgment associated with this. This is just for you to get to make sure that you're ready and prepared for physics or Chem 11. The second thing is I am not a math teacher. That is my brother's domain. I teach AP Chem 12 and I teach AP Bio 12. So I am not an algebra teacher, but I'm going to give it my best shot. So please bear with me as I go through this, as we go through a few examples. Okay. I guess the last thing here is that if you are lights out at this stuff, I apologize for making you watch me. But you never know, maybe you might learn something and maybe you can give me a piece of advice as to what to do differently. All right, so I'm going to share my screen now. So hopefully what you're seeing here is my OneNote screen. This is in my AP Biology notes, so they're going to be confused. So I'm going to start, I hope, with a fairly easy example. And we're going to be looking at the classic F equals MA. And what we're going to do is we're going to solve for variable A. Okay. Now, one of the things that I found as a kid when I was going through algebra was, even though it's more work, going through all the different steps, because that sort of keeps you straight and tries to minimize issues. So we're trying to isolate variable A, acceleration here. So right now it's attached onto mass, or M. So we need to isolate A and get it away from M. So right now A is being multiplied by M. So to undo that, I need to divide both sides by M. Now again, many of you would not do this. I'm just doing this to show all the extra background information here. M over M, something over itself, ends up canceling it off. And so I've now got F over M equals A. So I've successfully isolated variable A. One thing in science that we typically do, which might be a little different than math, is we tend to isolate and solve for variables in equations like F equals ma without numbers. We leave the numbers till last, all right? So if this was, say, an equation in your Physics 11 class that you would do next year, our recommendation is to leave out numbers until you've isolated for the variable, like I've done here for A. So moving right along here, another very famous equation. Okay, Einstein's very famous E equals mc squared. And what I'm looking to do is I want to solve for a constant, the speed of light. I want to solve for C. So very similar to the previous example is I've got mass being multiplied by C. So I need to isolate C and get it on its own first. So I need to divide both sides by M. So just as in the example above, something over itself cancels it off. So right now we've got E over M equals C squared. Now I just want C. I don't want C squared. So I have to get rid of that square. And I do that by taking the square root. So for square root of E over M equals the square root of C squared. Now the square root of something that's squared means that cancels off. So I've got now E over M equals, or square root, sorry, of E over M equals C. Okay, another one here, one that's used in chem, is D equals M over V. So we're looking for density here is mass over volume. And let's say in this example, I want to solve for V. So right now, the volume is on the denominator of M over V. So I've got to get V out of there. So to do that, I'm going to need to multiply both sides by V. So dV then, D times V, is equal to mV over V. Means something over itself, means it cancels. So now I'm stuck with dV equals M. Now it's better, I've gotten V off of the denominator, but I still have to isolate it. And right now it's attached onto D. So I gotta divide both sides by D. Cancels those off. And then volume is equal to mass over density. Okay. Another example, a bit more complicated looking of an equation, but you follow the same principles. F is equal to K Q1 Q2 or R squared. And in this example, I'm looking to solve for Q1. So Q1 is in the middle here of a bunch of other variables, K, Q2, and R squared. So first thing I'm going to do is I'm going to get rid of that R squared. I'm going to go through this through quite a few steps. So R squared right now is on the denominator. I got to get rid of that. So I got to multiply both sides by R squared. So these now end up canceling each other. So now I've got F R squared equals K Q1 Q2. So we're better again, but we're still got K and Q2 attached onto Q1, and they're both multiplying against Q1. So I'm going to do a double whammy here. I'm going to divide both sides to get rid of that multiplication by K and Q2. And so when I do that, I have the K canceling off, the Q2 canceling off, and I've now got F times R squared over K times Q2 equals to Q1. So even though the formula was a bit more complicated, the general principles are the exact same. Here's another example. E sub K is equal to a half mv squared. I use this to find the kinetic energy of a particle or an object by taking the mass and the velocity squared times by a half. And in this example, what I'm going to do is I'm going to solve for the mass. I'm going to solve for variable m. Again, m is in the midst of a bunch of other components here. It's got the half in front of it, and it's being multiplied by v squared. So first thing I'm going to do is I'm going to get rid of that half. So how do we get rid of something that's a half? 1 over 2. I multiply it, everything, by 2. So 2 times a half ends up canceling those terms off. So now I've got 2ek is equal to mv squared. So again, this time I've got mass being multiplied times velocity squared, or v squared. I am going to get rid of v squared by dividing both sides by v squared. Those cancel. And so I've got 2 times e sub k divided by velocity squared of v squared equals to m. So the last one I'm going to do with you here is isolation of the variable with the trig function, sine function. So sine theta is equal to length x over length y. And I'm going to solve for theta. So I want this angle, theta. Right now, it's got the sine function attached onto it. So how do I do that? Well, I have to take the inverse function of sine. Now, that's got that denotation of sine to the -1 x over y. Now, you find that by pressing second function sine on your calculator. So you take length x and length y and divide them. After you press second function sine on your calculator, and you're going to get some angle, whatever that happens to be, theta in this case. Okay. So here are some basic examples of solving for a variable, which may come in handy for you, again, as you're taking physics or chem. If you're like lights out on this stuff, that's awesome. Like I said, if you need some more support on this, you know, there's a whole variety of science teachers that are willing to help you with this. And this is just a way for you to get a leg up and get started right away. Because particularly in Physics 11, you start right away having to rearrange algebraic formulas. So the stronger you are in that, the better and the easier the transition is going to be for you as you move into your Science 11 class. Okay? Thank you very much.